3, 2, 1, start.
Okay, people, we finally made it. Everyone who is in the call, thank you so much for staying with us, getting this whole thing together. It finally works. I hope so, at least. Now, before we get into our third lecture about developing applied AI use cases, I have two announcements to make. First one is considering our motivation form. So as you know, we have a second week in our AI4G workshop. And to get into this week, we ask you to fill out your Google Forms, I think that David shared on Slack, where you can state your motivation, why you want to be part of on some very cool use case, and if you have team members. And so this is one thing. The other cool thing, also very recent announcement, is that we have another lecture coming up, actually, that will be held by someone from Google. It is, I think, already live on LinkedIn. So if you care to just type in TUM.ai, then you will see that we have a very cool lecture coming up, going a bit more into detail, right? We have had some requests of you guys wanting to see a bit more of coding. So in Google, we can dive a bit more into this coding perspective. And I think with this, I will start this lecture. So first of all, let me quickly introduce myself. I'm Patrick. I'm in my final years at TUM in my master's. I'm also part of the venture team at TUM.ai. And in general, why am I here? I'm really interested or passionate about solving actual problems, solving real world problems with what this whole workshop is about, right? This is what you guys can do in the second week. You can think of awesome use cases and try to use them with AI. And of course, if someone is interested in connecting or wants to reach out, just here you can find my account. Now, to the lecture overview. We'll start off with a bit of theory, namely how to design products, right? How to develop products in a structured way, and specifically what this means in a AI context, meaning we will be looking at design thinking and how to develop AI-powered products. In the second part, in a specific use case, namely a computer vision use case, and if everything works, I hope it does, we'll have our own functioning machine learning model in the end, without writing one single line of code, which is pretty awesome, and you'll see later how this works. And finally, the third part will be about everyone who is interested in our second week and who wants to, kick off his own AI journey. And in the beginning, I thought of having a little warm up. I do hope that we have enough people in the call who are willing to participate in a quick quiz. So what we have here is a question. I'll just read it out loud. What statement holds true about AI? And we have three options. Option is artificial intelligence and machine learning the same. Second option would be, for machine learning, you always need vast amounts of data, as we have talked a lot about data, and the third option will be, machine learning depends on human intervention. So I don't know if you guys can talk, but perhaps you can write into the chat what you think, if option 1 is correct, if option 2 is correct, or if option 3 is correct, or maybe options are correct. As I can't see the chat, David, maybe we'll give them, a few seconds, and if someone cares to write something, then just tell me.
Yeah, of course I want to write.
Take your time.
Some people say option 2 is correct.
Option 2 is correct. Okay.
We have someone else is writing.
Let's wait.
Then we have, I think option 2 and 3 are correct from Kapai.
Options 2 and 3 are correct. Okay, let's resolve the mystery. Let's start with the first option. So option 1 is incorrect. I get that you have well listened to David in his first lecture. It is, of course, not only machine learning, but AI is sort of the whole field, also including rule-based systems. And then machine learning is specifically considering the type of machine or the type of artificial intelligence which is data-driven, right? And then again, of course, you have deep learning where you try to tackle these data-driven problems with neural networks. This is kind of the definition of deep learning. Second option, now you don't need always vast amounts of data. There are a lot of examples where we have created state-of-the-art models like GPT-3 that was trained on huge amounts of data. But the cool thing is that we can use a thing called transfer learning. And what this means is that we have the capability of using pre-trained models, meaning models that have already seen some training examples, and we can just fine-tune it to our specific use case. So in our talk tomorrow, our expert from Google will talk about how you can make use of already existing trained models and just, a few examples so that they work on your use case. And finally, of course, option 3 is correct because, of course, AI systems don't evolve themselves yet. We are still in a phase where they rely on humans to actually code or humans to actually be involved in this whole process. And with this, let's have a quick recap of what we'll be looking at or how our lectures correlate to this one. I will be picking, as I mentioned before, the computer vision use case, more specific object detection use case, and we'll be looking into that, or we'll be applying design thinking to that use case. And another, the evaluation criteria that Flora in her lecture yesterday mentioned and presented. And I just listed them here again. You don't, of course, need to have memorized all of them. It's just to think about these criteria while developing your AI project. And without further ado, let's just jump right into design thinking. Now, design thinking, I hope that perhaps some of you have already heard of design thinking. I would generally just describe it as a technique, as a method to develop solutions, specific problems. And you have mainly 3 different perspectives here. You have, first of all, the feasibility aspect. And as in our audience, I think this is kind of obvious that you have to make sure that your solution somehow works, that your product works function-wise. And then at the same time, of course, you have viability, which is, does this product make also from a business perspective sense and make money with? And finally, of course, we have the desirability aspect. And this is, I think, the most important part in design thinking. You have to start with the people. You have to start with someone, with some target group, and look at their needs, their problems in a way, and then you will try to solve them. Finally, we have also the sustainability aspect that is not specifically included in the framework, but I think it's relevant for our course here. And this considers, of course, what might be a wider impact that I have with my idea. How can I perhaps benefit society as a whole with my idea or solution? And more specifically, design thinking is composed of 5 major steps, and you can use these 5 steps in your. You start off with empathizing, meaning you try to understand people, try to see what needs they have. And then in the second step, you try to define a specific problem, which is the define step. And then you are sort of going into a solution space where you try to ideate, come up with different solutions, and then you try to implement those solutions as prototypes and test these prototypes. This is roughly this process, and that's the most important part here is that we have this sort of infinite loop, right? And this just means that, of course, you won't get it right the first time, meaning you will have to revisit these steps over and over again to iterate, to optimize your product in the end. And this is why we have this kind of loop here. And now, of course, we are intelligence lecturer, kind of. And what interests us most is what does design thinking mean for AI projects, right? And in general, I would say not a lot changes, right? We still have a product sort of that we want to develop. It is just machine learning powered, let's say. We have a data or machine learning part in this product. And this means that we have this sort of additional layer, right? The empathize step, for example, we also have to think about collecting data. In the define step, we also have to think about exploring this data, analyzing this data, to then transformation step so that we can input it into some kind of model, some kind of machine learning model in the prototyping step. And finally, in the test step, we will, and of course, you know, try to increase the accuracy of the we are doing with this machine learning model. And with this, I will try to very briefly get a bit deeper into these different steps. I don't want to really bore you to death with this. It's just to give you a good understanding. 5 steps in the design thinking process are, and then later on we'll see how this looks in an actual use case. So in the first empathize step, as I previously mentioned, we want to identify the fundamentals of a target group. This could, for example, mean that picking, for example, agriculture, right? In the agriculture domain, we have, for example, farmers. And if we want to solve a problem of farmers, we need to understand them. We can interview them, we can immerse ourselves in their workflow and really get their deepest needs, kind of. And this will then be our foundation. And this is the use case side of things. And then I mentioned we have additionally, because we're in an AI project here, we're trying to develop a machine learning product. We have the AI sides of things, right? And the first crucial question to ask is, why could AI make sense here? As Flora, I think, already mentioned, we see often people just trying directly to apply machine learning models, like directly trying AI as a solution. However, this is not necessarily always the best, meaning you have to carefully think, what are my, of course, use the evaluation criteria that we just showed you before, right? Emma, have I got data available, and so forth. And then in the next step, in the define step, case perspective, we try to formulate a very specific problem statement. Taking again the example of agriculture, let's say the most important problems of a farmer is that he can't predict the weather. Okay, let's say that due to some unsuspected weather or rainfalls, farmers lose a significant amount of their harvest every year. So our problem statement would focus, and here you can see this kind of sentence that you can form, very easy sentence where you could say farmers needs, well, or a farmer needs to know how the weather is evolving, because otherwise he loses his harvest. This is a very, very clear problem statement, and this is how you would, or how you should start off with. Because the clearer your problem statement is, the better you can think about solving it. And then again, to have the AI sides of things, we of course have collected data. To go quickly back in our empathize step, in the blue box here, we collected some kind of data, right? In an agriculture use case, this would mean that probably we have satellite data or we have temperature data somewhere, because the farmer obviously himself does not have some technical data or something. So we will need to think about where to get this data in the empathize step. And then in the define step, we will try to analyze this data. We will try to understand the data. Sorry, just a call. I'm back. So in the define step, we will be trying to analyze the data we have and to understand it, meaning we will try to visualize it and we will check for missing values, because normally in practice, you always have incomplete data. You always have to check what kind of data you have. And this leads us to our third step, which is the ideation step. So we're kind of the solution space into the problem space. The other way around. We're moving from the problem space into the solution space, meaning, again, taking the farmer as an example, we know that farmers have difficulties predicting the weather and therefore lose their harvest. And now we think of solving this problem. We try to generate as many ideas as possible without judging or evaluating them, just come up with very crazy ideas, something like, okay, all over Africa or something, to prevent farmers having different weathers or unpredicted weather. This is, of course, a solution that would never work, but we were just trying to create as many or generate as many ideas as possible on the use case perspective. And then on the AI perspective again, we have now analyzed our data, and what we now try is we try to transform it. And transforming means that we try to select features. Now, you might have heard of feature engineering, and this is, of course, a very evolved topic and that you can't really explain in just a minute. But to explain it in a simple way is that you try to select what kind of characteristic of my data will be relevant for my machine learning model. So in this case, let's say the weather is influenced by temperature. The weather is influenced by pressure. So these will be features in my data set that I will be selecting, that I will be that I will try to keep, so that to input it into my model, right? And I mean, if you want, of course, you can go deeper into that topic. I think this is sufficient to know. And in the fourth and not last, but in the fourth step, we will try from the use case perspective again, we will try to implement the idea we had, right? We will try to implement as fast as possible, to test it with actual people, to see if we're correct, to see if we're actually solving the problem. And on the AI side of things, this again means modeling, meaning as I mentioned before, we now have transformed our data and have it as in a format that is that we can input directly into our machine learning models. And to be a bit more specific here, let's say in our agriculture use case, we have some kind of time series, meaning we want to predict when does the next heavy rainfall occur. And for this, we have some historic data on rainfalls occurring on a specific location. And then, for example, we can use deep generative models to kind of as models and input the data into those models to make a prediction. And this prediction then will, of course, be tested, right? Here on the AI side of things, again, you will test your model performance. You will have performance metrics. You will probably have heard of accuracy, of perhaps recall or precision. And these are specific metrics that we will be looking into later on, that you can use to measure how good your predictions are. So you will be training a model that predicts, in this case, the weather, right? And important, or not to forget, of course, is the use case side of things, where you have to think about how to integrating this kind of machine learning model into a holistic product, right? Normally, machine models are not an entire product. right? You have to think of it more as a part of a product. So you have to think about, how will I integrate this machine learning model into my complete service? And in this case, you will have to think about some kind of application on a mobile device or something that farmers can use to as an interface to your model, as an interface to make this inference on your machine learning model to see how the weather is changing and how the weather will change in the future. Now, this is everything concerning theory, concerning methodology. I hope it was not too abstract, that you kind of got the idea. To know is that you have these 5 steps of empathizing, defining, ideating, prototyping, and testing, and that you try to come from problems to solutions, right? In a user-centered way, kind of. And now we'll be looking at a computer vision use case. And before we do so, I want to introduce you to a tool that we'll be using, namely Vertex AI. Now, Vertex AI is a brand new tool from Google that I would describe as a sort of unified AI platform. What it enables you is that you can very, very easily create machine learning models without writing a single line of code. Meaning, for a lot of you guys who are probably not extremely deep into data science or machine learning, this will be the perfect opportunity to really, really quickly have a functioning model. See how this works. And I will show you. I will show you the Google Cloud Platform later on. For now, if you yourself, after this lecture or for the next week, want to get deeper into Vertex AI, or also want to use it to create your use case, then I suggest that you just set up a free Google Cloud Platform account. That's super easy. I hope it works in Ghana. I'm pretty sure it does, though. And we'll be providing specifically lectures for you on our AI4Good Notion page. So there are tons of very, very cool tutorials showing you how to quickly get into Vertex AI and showing you how to use this tool. And coming back to our design thinking, first do design thinking in Vertex AI. We can create data sets, and I will show you later, but you can create 4 different types of data sets. And these dictate, I think we also had this question, these dictate the kinds of machine learning models that we'll be using then, right? And namely, you have video data that you can use, you have text data that you can use, you have tabular data that you can use, and you have image data that you can use. We'll be using, of course, image data later on. And then for the define step, you can visualize your analyze the data. For your ideation step, you can perform labeling. You can do this kind of data transformation that we talked about earlier. And you can, of course, prototype and test. And prototype and testing means, just to remind you, of course, creating the actual model and evaluating its performance, meaning seeing how good it predicts your given goal. Just so that you don't, Vertex AI only helps you creating, or only gives you a very simple way of developing your machine learning model. It doesn't give you anything else. So if you really want to think about a complete product, a complete service, then you will have to do the use case sides of things. So the gray side that we had earlier, you will have to do that on your own, or additionally, let's say. And with this, let's start with our use case. Finally, our use case is as follows. We want to create a face mask detector. Okay, this is a classical computer vision use case, and more specifically, it is object detection. So as you can see in the right picture, I hope you can even go there. You can see that this object detection algorithm, in this case, only classifies the faces of different people to having a mask on, or not having a mask on, right? Unmasked or masked. And to give this kind of, to not only show you how to create the machine learning model for this, but also to kind of use this as a starting point for creating an actual product, an actual machine learning powered product, we will start with the following situation, right? With the following assumption. We will say COVID-19 isn't over yet. We believe that face masks will become a lasting part of our society to ensure safety and prevent further spreading. We see a great potential market in automatic face mask detection, especially for public places like airports or train stations. Now, if you agree with the statement or not is not really relevant. We're just going to assume that it holds true. And our approach will be to apply our design thinking method, meaning to apply these 5 steps, to build a model on Vertex AI, and in the end, to combine these two things into a holistic product or service with actual business value, right? So let's see how far we go here. We start off again with the lame side of things with thinking about the use case, okay? I have picked the Munich airport as a public area we'll be looking at. And let's say we have conducted multiple interviews with the managing party of the airport, with security at the airport, with all the relevant stakeholders. And the following are our insights, are the insights that we generated from these interviews, right? We have, first of all, hundreds of people passing through Munich airport per day. This is kind of obvious. We have very limited security guards on site, and we have just too many people or too many travelers for these limited security guards, so that the security guards can check if they wear masks or they don't. So from our interviews, we gather that Munich airport problem of enforcing the COVID-19 restrictions, meaning to enforcing that everyone in the airport is really wearing his mask. Okay, this is what we found out from the use case side of things. Now, of course, we also need to think about what kind of data do we want to use. Okay. And in this case, what is kind of an intuitive choice, I would say, is to use video footage of surveillance. Okay. Now, at this point, of course, directly some bells in your head should ring, probably, because you will think about privacy, right? You will be thinking about, okay, if someone is constantly looking at this video footage, the people will know from a lot of people where they are at a specific time, and this kind of violates their privacy, right? But assuming that we just go with this data, because we can't find anything, and we're trying to use video footage of surveillance cameras. Now, in the second step, in the define step, we will now try to formulate very, very specific problem statements. Okay, and these are: wrongdoers cannot be contacted, meaning people who are not wearing their mask are in the current situation cannot be contacted because the people just don't know if they wear a mask or not. There are multiple people who are not wearing masks, and as the authorities don't know about it, they can't contact the people. They can't tell them, okay, please put on your mask. And the same thing, of course, goes about contacting authorities or alerting authorities. And another key problem that we identify is that the footage from the cameras is just so immense, that the amounts of data are so huge that manual processing is just not feasible, meaning it is just too expensive to pay the people to look constantly at this video footage to check if everyone wears a mask or not. And on the AI side of things, again, in this blue box here, we have analyzed the data, meaning we have looked at a few hours of video footage, probably, and let's assume we have gathered the following insights here. Again, we have seen that first of all, the surveillance cameras that are near the entrance of the airport, that they record obviously every person. So this is a good thing, right? We could perhaps use this somehow to make sure that everyone who's entering the airport wears a mask. And then we also observed that on average, 1 of every 1,000 passengers is hidden from camera, right? This is just a made up number, but it should just show you the way you should approach this kind of topic, right? You should try to really question what kind of data you have. And here you see, okay, 1 out of every 1,000 passengers are not a lot of passengers. But this is kind of uncertainty that you might have by using this kind of data to make sure that everyone wears a mask. Now, in the next step, in the ideation step, we again, as mentioned before, translate from problem space to solution space, okay? And the question we will ask ourselves here is, how might we increase the amount of people wearing face masks at Munich airport? This is kind of a very concise question. And based on that, we will try to ideate. Let's say we have ideated in our team for multiple days or multiple hours, and we came up with these 2 solutions. Okay, thought first of all, let's notify everyone who doesn't wear a mask based on our object detection algorithm. Okay, so every time we have our object detection algorithm seeing someone without a mask, this person should be contacted via SMS, for example. Okay, so that this person could, put on his or her mask. The other solution we thought it is, okay, why do we need to target everyone, every individual? We're only interested in keeping the number of people who are not wearing a mask low, right? So let's just create a threshold, an anonymous threshold of unmasked people, and sort of create this this density map, right? There are different locations in the Munich airport, for example, at Terminal 1, where a lot of people at a specific time are not wearing their masks. So let's just send a few security guards and tell them, please go to this terminal to make sure that the people put on their mask. So these are the kinds of 2 solutions that we thought about. And from, again, on the AI side of we will be thinking about the face mask detection algorithm. So we will be trying to use our footage, meaning our video, our data that we selected in the first steps. We'll try to use it so that we can input it into some kind of machine learning model. Now, the first thing here is, of course, or that comes to mind is, we don't need actually the whole image of this video footage, right? We only need this part, only need the face part of all people, because this is the part where you see if someone wears a mask or not, right? So this is one thing that we want to make sure. This is, by the way, what I said earlier about feature selection. In this case, let's say the feature that is important to us is the face. And another thing that is also common practice in data science projects, I would say, is that maybe we come up with the idea, okay, why should we even use the video footage, right? It's an awful lot of effort to kind of select the right footage and only look at the faces. Why not just take photos and images, masked and unmasked people, and try to learn on those kind of data, okay? And if you think about it, it makes kind of sense, right? Because videos are in a way nothing else than a sequence of photos, of images. So we will try to approximate our data by just creating another data set, a synthetic data set, if you will, of masked and unmasked images of people. And of course, the final step here is creating bounding boxes, so-called bounding boxes. You will see what this exactly is later on in our example, or on Vertex AI. And these will be our labels, meaning these will label if someone if someone wears a mask or if someone does not wear a mask. And okay, this was a lot of talking from my side. I hope you still are kind of there. I have a question. Now, what solution would you rather pursue? Going back, we saw, or I just told you that we assume that we came up with 2 alternative solutions to our problem, okay? So the first one was, let's use our automatic face mask detection and directly notify the individuals, directly notify via SMS or app or something, different users or different violators, different people who are not wearing their mask. And our second alternative solution was, let's also use the face mask detection, but let's only create an anonymous map with a density, for example, of people in a specific area. And then the only thing that security guards or something or the responsible people will get is probably something like an anonymous alert about a specific area within the airport to go to. And maybe you could, just write into the chat if you think it's solution 1 or solution 2 that you would prefer. And I mean, if someone is brave enough, of course, he or she can unmute him or herself and just state why. So would you go for the solution 1 to our problem or the solution 2? And bear in mind, of course, the problem was we have too many masked people, unmasked people in the board, and we want to somehow reduce this number. We make sure that as many people as possible wear their mask.
So we have one answer. Pamela
yes,
answered
nice.
idea 1 without explanation, but yeah, idea 1.
Idea 1. Okay. Okay, I'll just go with that. Let's say Pamela said, okay, she wants idea 1. Now, it would of course be great to hear why, but let's just assume that we just said to have idea 1 because it's just direct, right? You can directly tell violators or unmasked people, please put on your mask, and then you're done, right? The only problem with this is that we have privacy. Okay. In the first idea, if you think about it, it would mean that not only you have to detect a specific face, but you have to know who exactly is that person, right? You would need to know what person this is, and only then you would be able to them some kind of app or some kind of message or some kind of SMS. And this kind of violates privacy, right? This is a typical use case where you would need to think about how to proceed here, because it might be, of course, that okay, you find some kind of technical way so that you don't have to know exactly who this person is, but assuming you do need to know, you need to have some kind of huge database where you have every face in to kind of match it, right? To see, okay, for example, David is not wearing his mask at the airport, and I want to send to his phone number that he should put on his mask, and this would kind of feel a bit unsure. I'm sure for David, right? He would feel a bit vulnerable. He would feel like everyone knows who he is, kind of. And in this case, the point is just that we don't need it, right? We don't need to know who the individual. There are people who are not masked, and we want to just make sure that they put on their mask. So we will just go with idea 2 in this case, to not violate any privacy of people. Okay. Now let's finally have a quick view of how Vertex AI looks like. I do hope that the screen recording is working, that I can just go into my console here. David, I'm okay, super, perfect. So what you can see here now, perhaps I'll just go to the dashboard first. And what you can see here is Vertex AI, okay, the console. I have created a free account, and this is kind of the first dashboard page I will go to. And what you can see here, what's kind of interesting is that you have here the possibility of creating data sets, and you have here the possibility of creating models, and theoretically also to test these models with specific data, which basically batch prediction is referring to. Now, of course, I kind of prepared a little data set. Okay, I will go to data sets. And I have created a data set that is called object detector. And this data set looks as follows, okay? We have here, you can see all in all, 1,081 images that I uploaded of people who are masked or not masked or unmasked, called in this example. And a very important, of course, is the number of labeled, of actually labeled images. And as I mentioned before, labeled in this case means having these kind of bounding boxes, okay? So we have on one hand, the green bounding box, signaling the masked class, meaning we have for every person who wears a mask, we have a green bounding box. And for every person who doesn't wear a mask, we have a yellow bounding box. And in total, I have labeled myself 302 of these images. And I have made sure, of course, to have a balanced data set. And this means that I have roughly as many masked examples as unmasked examples, so as not to bias my machine learning model, okay? And another very interesting thing to see here, I don't think if all of you, I don't know if all of you directly noticed, is that these masks here, if you look closely, they're not actually worn by the people. They're just photoshopped onto just random images of people. And this shows you that kind of you can have some kind of little things or little tricks that you can use to be more efficient. Okay, so the data set, I didn't create the data set myself. I just downloaded it from the internet. From you can find the sources on that also on our Notion page. And the creator of this data set was really smart because first of all, she thought to herself, okay, why do I have to take 1,000 pictures of different people and then make sure that 500 of these people wear masks and 500 don't? And of course, 1,000 images is nothing. You have data sets with very, very multiple thousands of data points, and it's impossible to all do it manually, or it takes a lot of time. You could just source random images from the internet and just Photoshop to a part of them this kind of face mask. And I mean, the details of how to do that is also written in our Notion page. But for now, this is kind of everything you need to know about creating your data set, meaning of the third step of our design thinking process, meaning the ideation step. And we'll now go back to our presentation for now and continue with our prototype. Okay, so to recap real quickly, we have first of all empathized with the people at the Munich airport. We have seen that that a huge problem they have is that they can't enforce restrictions because they don't know how many people wear masks or how many don't. And then we kind of thought of a solution. We thought of, okay, make some sort of density map and track through our surveillance camera footage, track people who are not wearing masks without, specifically knowing who they are and sending alerts to actual security guards and tell them, okay, please go in this direction to tell the people to put on their mask. And our prototype will or could look something like this. We'll have, first of all, the local data processing, which will maybe be done on edge, meaning perhaps we'll have some kind of edge machine learning, because normally object detection algorithms are very very nicely integrated into devices on the edge. So we'll just assume that we can directly have inference, meaning have our deploy our trained machine learning model on this system, on the speed camera, and then we'll have some sort of web interface, perhaps that security personnel can. Percentage of unmasked people is displayed, and let's say if a specific threshold of, for example, 30%, meaning 30% of the people that are looked at don't wear masks, then a kind of alert is sent to the security personnel, and these, for example, would have some kind of application, some kind of guiding application, where you'll have a localization map, some sort of Google Maps just for the Munich airport. Let's visualize it like that, and then you have like densities or values, and the people or the security guards can see where there are different percentages of unmasked people. Now, this, I hope this doesn't sound too complicated. It's a very basic system, and the cool thing is that in a few minutes now we have gone through the whole process, or nearly the whole process, right? We are now in the prototype, and we already have at least conceptualized a working or a prototype. Let's see if it works or not. It still remains to be seen, of course. And now let's get back quickly to Vertex AI and see how training a model actually works on this platform. Okay, so we're still here. This is our data set that we have created, that we have labeled, and the only thing I need to do right now is to click on this button here, new model, and then I can see, okay, I have a data set which I called here object detector. Then I have implicitly created by Google an annotation set. Normally in machine learning projects, this is something, of course, you have to take care of, but it is automatically taken care of by Google in this case. And the interesting part, of course, are these different things here, these different options. Now, if you are already a bit more advanced, and probably I've seen some of you are computer scientists or are studying computer science, so maybe you already know some stuff about object detection. And in this case, you could just say, okay, I want to train a custom model. You know, I have the specific model architecture that I think is very good for this, and I want to try it out with the data that I created. And in this case, you would just press on this button, and you see that there are more options that you need to fill out. For example, you know, tuning the parameters and so forth. But more importantly, for all of you guys who are that deep into models, you can just click on the AutoML button. And as it says here, Google sort of will take care of what kind of model you use, right? They will take care that for this kind of data and for this task, in this case, having image data and having as task object detection, Google will make sure to pick kind of a state-of-the-art model that can handle this kind of data and that can do this kind of task. And of course, I have already done this. And what we can see here, if I go under training, we can see our model. I named it object detector model, or mod 1. I finished. Also, Google Vertex AI provides you with nodes where you can run or train your models on the cloud. And this is what my results are. Okay, but let's go back for a second before looking at the evaluation. And let's see what kind of evaluation metrics I have for evaluating my machine learning models. Okay. Another thing that I just forgot to show you, I'm just seeing it on the slide here, is that when training, you also have this option here. You will see it very directly if you go through the steps I just showed you. And this is concerning the data split. Now, data split, just you might have heard of that, refers to how to split your data to train your model, right? And normally you have three different types here. You have training data, you have validation data, and you have test data. Now, I would just suggest for all of you guys who are not extremely deep into training models, just leave it at the default of 80% training data, meaning 80% of the images that we labeled will be used for actual training, and 10% will be used in this, meaning we will show, very easily spoken, we will show 80% of images to our model. It will train on these. And then after that, we will check the performance of the model on our validation set, meaning 10% of our labeled images will be used to check how well it performs. And the test set finally, or the test subset of our data, which is in this case also 10%, can only, and this is important, can only be used once. Okay, normally this is like the first thing that you learn in machine learning courses, is that test data is only there to kind of get a feeling about your final model performance. Something that I wanted to mention, just to make sure that you understand what data split means. And getting now into our last part about testing. Now, the final step of our design thinking process is testing, and here we have a huge amount of different metrics that one can use to test the performance of machine learning models. Now, this of course depends on what kind of model you have, what kind of task you want to do. Are you, have you got classification or have you got regression? But in our case, and this is also what we saw earlier on the Vertex AI side of it, we'll see that later. We will use recall and precision. Now, some of you might have heard of those things. Nevertheless, we'll just briefly tell you what this means, so that you know how your model will be evaluated. Now, recall looks at what proportion of positive identifications was actually correct. This means that of all, normally you have two cases in classification, right? You have true or false, right? And in this case, as you can see also from the formula, you have true positives divided by true positives plus false negatives. And it means, okay, how many of my predictions that predicted true are actually true, meaning actually are the same as my ground truth, meaning same as my labels. I hope this is clear, because it only means that my model predicted different values for different ground truths, as we are in a supervised learning setting, and everything that it predicted positive, or the percentage of everything actually was positive that it predicted positive, is the recall. And precision is the same thing, just kind of inverted a bit, meaning there you look what proportion of actual positives was identified correctly. This kind of is showing you of ground truths being positive, how many did I identify correctly with my model? And you don't have to fully understand these two things here. We also have resources so that you can learn about them in detail or on your own and take your time. The important thing is just that those are important metrics that you will be using to evaluate the performance of the model that you train. And if we go back, just one last time, please stay with me, and look a bit more. We see, or at these numbers, we see, first of all, an average precision of 0.714. If you see you also have this kind of a question mark here, where Google offers you a quick, very helpful explanation of what this means, and then you see you have a precision of 96.6% of the model that I trained, recall 90.3%, and okay, this gives you or this can give you some kind of intuition about how well your model is performing. What you can also do is you can click, for example, on one specific class. As we have a classification problem here, we have here a precision for masked example, and here an average precision for unmasked examples. And the cool thing about Vertex AI is it even tells you how to improve your results, right? It tells you, okay, add more images that are visually similar to your false negatives and false positives. Ensure that they are labeled correctly, create a new model. What this in this case just means is that, for example, it shows me this image here was wrongly predicted by my model. And this might mean that in my data set that I showed my model, not enough images like that one existed. So what I will be trying to do, what I could do to increase performance of my model, I could try to just put in more of these types of images or similar, for example, intensity-wise, and then reevaluate my model. Now, of course, these metrics still might seem a bit abstract. So one thing we're going to do is we're going to test our model. What I did here is, and this is also a cool thing about Vertex AI, you can deploy your model that you trained directly to an endpoint. And what I will do right now is I will test it on an image that I earlier took of myself, meaning I will upload an image. I really hope it works. For example, that one. And we will upload it. And this will kind of perform inference on my photo. And as you can see here, it seems to work because it has identified here on the right, you can see the confidence scores of the model, right? You have here with a confidence of 0.60 or 0.685, you see that this is the most probable case, and this is actually where the object detection algorithm has located the relevant part of my face, and it even recognized a black mask, right, with a 0.685 confidence score. And all these other kind of bounding boxes here, of course, just predictions that are not correct, but that the algorithm thought possible. And here you see very little confidence scores for these other sorts of. Another thing I can do, of course, I can also go back and check, of course, the other case. I think I also have, let me see, I also have an image of myself not wearing a mask. So this is something I can also test. Just upload again an image of, let me see, this was a white mask, and this is an unmasked me. Let's see. Okay, now you see it has a significantly higher confidence of 0.943 that I am actually not wearing a mask, or that also this is the correct bounding box to choose, meaning that, okay, for some reason, it is significantly more confident for the unmasked case than the masked case. And this, of course, are things you have to think about, or factors you have to take into consideration when evaluating how safe, how trustworthy your machine learning model is. For example, if one case is much more safety critical than the other one, then I want to make sure to have a very high score on one of these one of these cases. For example, in this case, it's probably better that it has high confidence that I'm not wearing a mask, because this will, of course, be used in our airport use case to indicate to security personnel to come to me and tell me, please put on your mask. Okay. Now, I hope this kind of shows you how easy it is with Vertex AI to create your model, right? This is everything we need to do. Just a few clicks, and we have our trained model here that we can really test with actual data. And we are now almost at the end of this presentation. The only thing that remains is a general view of the test phase, right? The test phase is the last phase in our design thinking process, and the important part about this slide is that while testing, there are different things you can test for. Okay. Now, in this first column here on the left, we are looking at first of all, gray again being the use case perspective, and blue being the AI perspective. We're again looking on things that we might have done wrong with the problem formulation. Meaning, this has nothing to do with what kind of solution we came up with or what kind of model we trained. This is really questioning if we even formulated or selected the right problem. In this case, we could ask ourselves from a use case perspective, okay, pandemics might be here to stay, but wouldn't checking distances be more effective? Meaning this would kind of destroy all else what we did, right? Everything that we did after that would then be irrelevant if instead of trying to determine if someone wears a mask or not, we would try to make sure that the distances between people are kept. This is something completely different. Then, of course, also from the AI sides of things, in the blue box here, you could say, okay, I could also use totally different data. Let's say, okay, I don't want to use video footage or surveillance cameras because, I don't know, due to privacy reasons, this is something I don't want to do. Maybe I can approach the travelers themselves. Maybe I can, program some kind of application to get their data and try to convince every individual without violating his privacy of wearing his mask. So this again shows I can also just use totally different data, and all the steps after that are kind of ruined. And this is why we call this left side the problem framing was incorrect. And then I would go back to step E and step D, meaning the empathize step and the define step, to reiterate there, to start all over again. The same thing applies for the second column here, or the middle column here, and the right column. And again here, the middle column is referring to our solution. It might be that the problem that we formulated, meaning that people should wear, or more people should wear masks to prevent pandemics from spreading, was correct, but our solution was just wrong. Meaning it could be that, for example, this is important in this gray box here, that AI is not needed at all, right? Why just not define a general fine, finding people who are not wearing their mask, and be done with this topic? Maybe this is just as efficient as thinking of a complex system that detects if people wear a mask or not. So this kind of brings you back, right? This is something that if you have your cool idea in mind, kind of brings you back to the ground and lets you think if this is even necessary, if this technical monstrosity is even necessary to actually create the value or the solution you need. And in the blue case here again, for the solution, we might say perhaps it's better actually to use video data instead of image data. I mean, I mentioned before, you can have this approximation. Maybe it saves you some time, but it could also well be that this leads your model to be not as accurate, not as good or quality-wise good as the model that you could have with using video data or the whole video footage. And then finally, we have something that has the least impact on our design thinking process. Let's say you assume that the problem statement is correct. You assume that the solution approach is correct, but finally, maybe the prototype is not correct. Maybe we have a better way of implementing the prototype, and this will be, for example, is an interface even necessary? So if you remember, we had these three parts. We had this on-edge machine learning algorithm. We had this web interface, and then we have the application that the security people are using. And maybe we don't need an interface at all. Maybe this could be something that communicates directly between the cameras and the applications. Or looking at the data, looking at the AI sides of things, maybe I can use another model. Maybe I can achieve a higher average precision by using some kind of other machine learning model. In this case, I wrote YOLO because this is, you can look that up. This is kind of the state of the art in object detection right now, and maybe this would be way better than the way we did it. Or would result in higher. This was our case study. I think we're already at 1 hour 49. If there are still people here, I'm really glad. I have one last question. which is, what can you do when your model predictions are wrong? I just thought this is a question that is fundamental. And our option one is, of course, we can look for graceful ways to handle the inevitable cases where the algorithm fails. Meaning, we will definitely have, or the option one says we will definitely have cases where the algorithm fails, and we need to think about ways to handle this, or to handle this case. The option two says, okay, look at the cases where the algorithm is misclassifying data that it was trained on, and then these are almost always mislabeled or strange edge cases. Meaning, if our model is somehow wrong, we still have the opportunity to use another kind of data to look if perhaps it's just some kind of very strange case that never happens, and to correct the model. And I hope the question is clear. Perhaps again, David, I hope that we at least have one answer, or one guess. Which of these options you think is correct?
I will still
or is wrong.
the answers. No answers so far. But actually, one remark from my side: we're an hour and 10 minutes into the streaming, so it's not 2 hours. Like I said.
Okay, perfect.
Yeah.
Perfect. Then we do have time.
Yeah, we have option two from someone.
Okay, option two. I just realized, I think I phrased it wrong when I said it last. So the question is option one or option two wrong? No, sorry. What can you do? Sorry, I kind of misread the question myself. What can you do when your model prediction are wrong? Okay, and someone says option two. Right, David?
Yeah, exactly.
Okay, let's see what kind of answer we have. This is of course correct, but the thing is both things are correct, and meaning that you do need to think about uncertainty when you have machine learning powered model, when you create or develop machine learning powered products. Meaning, here I wrote the term human in the loop, for example. This is something that is very interesting. This is a way perhaps you can make sure or you can deal with uncertainty, because the thing, of course, is with machine learning models is you deal with probabilities. You never have, or in general, you never have 100% accuracy in some kind of task. So you always need to think about cases where your algorithm fails, and this is vital in the whole product development process, right? This is something you definitely need to think about when developing machine learning. And option two is, of course, also correct, meaning if something is misclassified, if in this case our classification task has only a low accuracy, let's say, and as we saw, we only had 60% accuracy for the mask case of our machine learning model, then of course we have the option of looking at the data again and trying another kind of data. Of, maybe I missed some important features that I still can select and that will improve my performance. Now, with this, we are in our last part of the lecture, which is of course about you guys, or all of you who are still there, and it's about solving or finding your own use cases, finding your own problems that you want desperately to solve with AI. And looking at our schedule, we are almost done with our education week. So we had a great lecture from David. And now we're only done, or almost done, with the third lecture. What we did not include here is the technical lecture for all people who are interested in coding from Google tomorrow. And then, of course, very important are the deadlines. So everyone who thinks, okay, I really liked the project. I still like AI, or it seems really cool. Please fill out these, or please do these little assignments. They're really not hard if you have listened to the lectures or if you just have looked at our slides. And then secondly, there's that you have to submit until Friday 6 p.m. where you state, okay, why do you want to continue? What is your motivation, and perhaps also what kind of team you already have set up. And the venture week is now before you. Kind of you will have the whole venture week until Thursday to ideate, right? To just try exactly what we tried to show you here, to come up with a cool use case with an actual problem and try to solve it with machine learning powered product. And then, of course, on Friday, we will have our huge pitch competitions. The best of you guys will get the chance to pitch in front of an expert jury, and everything will also streamed live. So make sure to give it your all. And we really look forward to very, very cool use cases also from Ghana. Now, just very briefly about how you approach your own project, right? You have seen how AI development could look like. You have seen what kind of evaluation criteria you could use yourself to evaluate your AI product or idea. And here again, you can see what we'll be looking at kind of is first of all the problem statement, right? This would be specifically oriented towards, is this product solvable with AI, and why do you solve it with AI? Why do we use AI here? This is something, of course, the data collection will also be part of that. Then concerning data. And of course, a validation is always cool to have, meaning this is kind of referring to the test phase of the design thinking process, meaning what I already said. Think about why should this problem be used, should be tackled by AI, and specifically think about the robustness. Think about the safety. Is it some kind of task that could go horribly wrong and that could hurt people or something? Then you have to make sure that you have some kind of mechanism in place that prevents this from happening, right? And this is the same, of course, concerning privacy, concerning bias, and so on. And here, finally, lastly, some best practices. I think most of them I have already quite well covered. We have, first of all, don't start directly with AI, right? Try to find a problem that perhaps you yourself are passionate about, and then try to neutrally think about AI as one possible way of solving that problem. And second practice, of course, start simple. Now, especially if you're kind of new to this subject, you don't have to spend hours tweaking your model or tuning some kind of fancy machine learning model. But as you see, very, very basic models already perform well. And let me show you, the model I just showed you, I didn't reiterate at all. I didn't tweak anything. I just used the AutoML function of Google, and it gave me this kind of decent score directly. And then thirdly, don't fall in love too much with your prototype, right? This is a general design thinking practice, I would say. And this is concerning be rational, right? Try to build a prototype that is very easy and just show it to people, or in best cases, let them try it out. Let them try your prototype and really give you feedback if this solves their problem or not. And then, of course, concerning the AI sides of things again, don't directly start with models. I mean, don't directly think of what kind of fancy architecture you want to apply, but try to take your time and really manually look at the data. And often there are a lot of patterns that you yourself can already detect and that you can then use in the later stages. And with this, I'm at the end of my presentation. Thank you very much for attention. And if there are still people at this late time that have questions, please go ahead.
So far, we don't have any questions, but I suggest we wait for another 2 minutes, right?
Have you got any questions, David?
I've got a lot of questions, Patty. Yeah, I would say I really like it. By the way, I didn't think about, for example, sometimes I catch myself doing this pretty obvious error of first of all thinking about the model, and then starting to ideate what I have to do with it. And I think it's really important to take care of your solution, not just your model, just to think how would you apply it, where you would like to apply it.
Exactly, and this is of course also a chance for all of our attendees here, or all the students from Ghana. You don't have to be an expert to come up with a cool AI use case. These questions of whether AI is the right choice or not are questions that you don't necessarily need to be an expert for, right? You can just regard AI as some kind of tool that has certain capabilities, and then you can evaluate if this makes for your use case or not. Okay, does it look like there is still people having questions? Are there even still people in the call?
There are actually some people in the call. Well, in the YouTube,
are you
everywhere actually.
Okay.
But yeah, a bit silent.
All people who are in the Microsoft Teams, this is your chance, right? You can of course ask me any question, also on Slack, and I'll be happy to answer these. But don't be afraid, don't be shy. Ask anything that comes to mind.
There is actually one question.
Not, okay, cool.
How would you go with the B example from Flores? Flores presentation. Okay. How would you go? What's your idea?
What would be my approach?
Yeah.
Okay, I have to admit I don't exactly know what the use case was, but as I recall, it was something like detecting predators by the sound they make, right? And having audio data as input, and then try to come up with some kind of a model that can detect hornets or something, right?
Exactly.
Am I correct? Okay. Mm-hmm. Yeah. So I mean, this is a perfect example, I would say. The thing that you would probably do is you would start by identifying the problem, meaning you will start in the empathizing step. In this case, I would probably go even further, not saying, okay, the problem is that hornets attack bees, but the problem is more we have a bee population that is in the decrease, and we want to know what is the issue for that, or what is the reason for this. So I would probably invest a lot of time on really getting the actual problem right, and this would then probably be my empathize and my define step. And then of course simultaneously in those steps I would of what kind of data do I need. If actually hornets attacking bees is the main reason, then I think audio data seems pretty reasonable. Maybe you could also use visual data. Of course, bees don't have cameras, and bees don't have some kind of devices to capture audio. So you will definitely need to think about how to acquire data. And in this case, this would probably mean installing some kind of cameras or microphones near nests of bees at different locations, And then this is, of course, something that you also have to take into account. What kind of data will I be creating here? And how much will it cost me, also from a business perspective, to create it? And once, if we go with, let's say, because we had this object detection use case here, let's just say we would go with visual data. So we would have some kind of camera there and installed at multiple different bee nests. And then the second step, of course, would be to analyze this data, right? In the define step, we would formulate the specific problem statement. Maybe this would be, okay, hornets are, or bees nests are getting closer to hornets because humans, humans are expanding, which is, of course, a total guess from my side. And then on the data side of things, I would think about, I would look at my videos, my video footage of the nests, and see if there are some patterns. If perhaps at a certain time of the day, hornets attack these nests, or if perhaps they always come in groups, or if they always come from a certain direction. Especially, perhaps I would choose different bee nests that are kind of near each other, and then I could try to track the movement of the hornets to see where they are and why they are, or at what time they are where. And then this is, of course, also a very cool use case for then the ideation step, meaning I would kind of think of prepare of features that I would select, meaning probably in this case, interesting would probably be time and location. So I would try to see where the hornets are at a specific time and a specific or at what specific location. And then I would probably in the prototyping step think about what kind of model will I use. And this, of course, could be solved with deep generative models, because I don't know if you guys heard, but there's, of course, this famous or DeepMind developed that has this weather forecasting or very, very near-term weather forecasting. And this is also based on deep generative models. And with these, you can kind of give uncertainties for different times or locations. And this would perhaps be relevant in this case, but this doesn't matter, of course. This is just me improvising here. The important part would to also regard the use case, right? To think about the data and simultaneously think about how would my product look. And this is actually a question that is not answer. I don't know what kind of product in the end I would sell. Like what kind? How would my complete prototype look like? Perhaps it would be some kind of machine or something that can be installed near bee nests that shoots every hornet that gets too close to a nest or something. But then again, I'm pretty sure that this is not the perfect solution for that. But this is the way you will try to iterate, to come up with an idea, and you will start at the beginning. And I think this is a very interesting use case. I can't tell you the perfect solution, but maybe you can work that out in the second week, in the venture week.
Actually, speaking about weather, we have another question.
Okay,
how
cool.
do you approach a typical time series based project, for example, weather prediction? What tools would you use?
What tools? Okay, definitely have a look at this recent breakthrough from DeepMind, which is, I think, in general, just very interesting. And weather forecasting in general is, I think, a very hard problem, right? We have huge weather models that are used by different research institutes, and this kind of breakthrough of DeepMind is probably something that is also pretty advanced. But this doesn't mean that you can't kind of a problem, because especially if we think about agriculture, this might be something that is really relevant for farmers, and really helps them to not lose their harvest or something. And the way I would probably approach this is to, in general, use Vertex AI in this case. I'm just thinking of showing you one more thing here. I mean, if I go to my dashboard, you know, I don't know how advanced you are already with machine learning, but if you aren't, one thing you can definitely do is you could create a data set here. And what you see here is that you have these 4 different types of data I spoke about, right? You have this image data, you have tabular data, and you have text data and video data. And here you have different classical tasks that involve, in this case, video data. And for this weather forecasting use case, this is of course tabular data. You could probably go into this direction here because they have a dedicated forecasting use case. And I even think that there are tutorials online where someone from Google's is explaining a very easy time series use case. So the typical way you would approach this, of course, is first of all having some kind of data, some kind of historical data about your specific location or the location you're interested in, and the way it works normally is that you look at history, meaning how often or at what intervals did a specific event occur. Meaning, you know, in the last 10 years, in some specific area in Ghana, for example, how often did heavy rainfalls occur? And then from there, you can predict the future, kind of, right? This is very, very simply said, a way you could do forecasting. And I would probably go it this way, meaning try out our framework, very easily said. I mean, start with collecting data, start with the actual people that are relevant here, maybe farmers, maybe weather institutions, maybe the government. All these are relevant stakeholders, I think, in this case, and see what kind of data is available. If there is, and there's, I bet there is, very, very cool data that you can use to create some kind of forecasting model for weather predictions. I hope this kind of answers the question. I mean, everything else is then going from there, kind of what kind of model you use. You could also do it with Vertex AI, just use the auto ML function probably. And if you do face some issues or problems, then just write us on Slack and we'll be happy to help you there.
Thank you, Patty. Actually, one more question. And yeah,
yes.
You have talked about recall and precision. How to determine which one is more relevant in my case?
This is a very good question. It's very hard to decide, let's say. It really depends on the use case, I would say. I mean, let's go back to the training and our model evaluation. And I mean, you can see here precision and recall are kind of very similar here, right? Or let's say 6% more here in precision. But as that, the difference of these two is that in the as it states here in the precision case, I am evaluating something else, right? I'm evaluating what kind of the percentage of predictions that were correct or the positive predictions that I predicted. What was the percentage of being correct? Meaning perhaps it's easier to show it with the actual formula, because then it means just something slightly different, and then you will have to decide based on your case what is more important. Meaning here you could say the recall is dedicated or is describing the proportion of positive identifications, meaning the proportions of predictions that I predicted positive and that actually were positive. And this is the precision use case, and the recall is what proportions of the positive identification was actually, no, sorry, I mixed them up. The recall one is what proportion, meaning of the positive example that I predicted, how many were actually correct, how many were actually positive. And the precision one is of the actual positive, how many did I identify correctly. So you get kind of the difference between those two, right? And you have to think in this case about what is more important in my specific use case. Is it more important to have the correct proportion, or to have a high proportion of actual positives that I identify correctly, or is it more important to have a proportion of positive identifications that were actually correct? This might still seem very abstract, and hard to kind of relate to real use cases. A very good source I would definitely say you go to, or you can look at, is here, this link, developers.google.com, and they will give you a very example of what the difference between those two are. And then of course there's also this precision recall curve, right, where you kind of combine these two metrics, and depending on your use case, you have like tons of different metrics. And I would probably Google very easily and see, okay, what kind of metric do I use for my specific model? And if I have a regression problem, probably you will at any rate more be evaluating with some kind of distance measure, right? You would perhaps use mean squared error or something. So it's something totally different in this case. This again depends on what kind of data you use and what kind of model you have. And the easiest way, of course, I didn't mention that previously, is looking at the accuracy, right? This is something that is very intuitive and that everyone kind of understands. Accuracy just means how many of my predict, or the number of correctly predicted divided by the number of the total total data points, right? This just gives you the percentage of how many of my predictions are correct. And normally this always already gives you some decent indicators whether your model is performing okay, let's say, if it's performing reasonably well.
Yeah, I guess
I hope this.
that's
Yeah.
it. We have some minor questions, but you answered already.
Cool. Very nice, guys, that you're still here and asking questions. That's cool.
Yeah.
But yeah, anyways, is there something major new? Something
No.
you still want to?
I guess you covered everything in the last two questions. Yeah.
Okay. In that case, people, thank you very much for joining again. I hope this kind of helped you a bit. If there's else that comes up later, write me. I will try to be with you as quick as possible, and I do hope that you will participate in the second week and show us what you have learned and show us already have in mind. And with this, I wish you all the best and good luck. Hopefully see you in the next week. See you guys.